Indeed, we led a scoping review, and we identified 40 papers based on the individual nutrition surveys, and who had a specific, we were specifically addressing food consumed away from home, and most of there is a tendency, there is an overrepresentation of some countries as Brazil, China, and Indonesia. So if you left aside those countries, you will see that we really have little household consumption expenditure surveys is much cheaper and is led in routine in many low and middle income countries. So our objective was to develop, field test, and validate specific individual level surveys modules to be added to household consumption expenditure surveys. And we wanted with those modules we developed to assess the economic and nutritional importance of eating out phenomenon. So basically our methodology, the main principle of our methodology was to compare the information we can obtain from 24-hour recall, dietary recall, that is considered in our case as the gold standard, with information we get from the modules we developed. And we developed two modules. One is based on one is so-called the shortlist modules, and it's based on a list of 30 food items frequently consumed away from home. And the other modules was made based on a long list modules, like it was 100 food items. And in each case, we recall information at the individual level on the frequency of consumption of each food items by the individual over the last 7 days. And we recorded information about the budget allocated to this consumption away from home. And then we compare the information we get on the monetary criteria, basically budget, expenditures, and on the nutritional criteria, much more indicators were recorded because we had the total caloric intake, the macro composition, the micronutrient composition, and we use free statistics to compare the proximity of the information from our modules to the one from the 24-hour recall dietary surveys. So this is the survey, or experimental survey design. Basically, in Vietnam and Burkina, each households we randomly selected adults. In Burkina Faso, we had a special design because we wanted to work on the intra-household aspects. And those individuals were randomly assigned either to a shortlist module or to the long list module. And basically, we compared the information from those modules to the one obtained with the 24-hour recall. And we made, within the same week, we made 3 visits, and each tested information with our modules as well. So I'll give you a few descriptive statistics on the importance of food away from home, the consumption. Like in Burkina Faso, 80% of the individuals had been eating away from their homes at least something, one food item on the day before. And in Vietnam, it was a bit lower with 65%. So it's very frequent. We can look at this frequency depending on the location of those individuals. And indeed, we came to kind of counterintuitive result, is that it was less frequent in cities than in villages. So we thought it could be related to the fact that we led those surveys in post-COVID situation, and maybe some in the cities people may be more reluctant about some contamination or food safety issues. We can compare those frequencies against depending on the sex of the individual. So it's more frequent in case of male consumers than female ones, which is coherent with what we found in the literature. And now if we get to the budget that was spent by those consumers, we get to average numbers of 42 cents in Burkina Faso per capita per day, and of 36 cents in Vietnam per capita per day. So this is quite important amount if we consider the incomes of those countries. And this is consistent with the data we had from LSMS data on Vietnam. And this is much higher than the data we had on LSMS in Burkina. Now, if we look at the descriptive statistics on the total caloric intake, in Burkina Faso, we have an intake from the food consumed away from home that is around 900 calories per capita per day. And this is quite an important amount because it is representing, if we relate it to the total caloric intake, 28%. Okay, and so in Vietnam it's still important. And then about the validation of our modules, no, if we compare the information we get from our modules to the one obtained within the 24-hour recall surveys, we get on the, if we look at the budget data, with the modules we develop values that are higher than the one obtained with the 24 hours recall surveys. And this is like, we have this overestimation both in Burkina Faso and in Vietnam. And the overestimation tend to be higher in the case of long lists, which could be easily understandable. And it's the same with the, if we look at the, so if we look at the Spearman rank relation, Wilcoxon, and if we look at the Blunt Altman, it's the, we have this V shape that means that the higher the estimation, the higher the misestimation. So, and now the same kind of results, but looking at the nutritional criteria. So I only presenting the results on the total caloric intake. So when we consider our modules, we will underestimate the energy intakes that's coming from the consumption away from home. And this is the same results in Burkina Faso and Vietnam. And the gap is higher in the case of the shortlist, meaning we are doing worse with the shortlist than with the longer list. So, and if you look at the Bland-Altman plots, again, that's the same V shape. So as a conclusion, like, and those results that are on the total caloric intake, basically they are the same if we look at the protein contents, fats, carbohydrates, and even at some micronutrients we could work on. So we have an overestimation of budget with our modules compared to the 24-hour recall, and another estimation of nutritional nutritional information with our modules. So we will, I'm happy to have more discussion on this. We had some thoughts about what could be the reasons that led to this either overestimation or underestimation. And yeah, we think that more work is needed, like to work better over modules. Thank you.
A wonderful presentation. Elode, she is an Animana fellow. She talked about how to measure. She talked about how to measure food consumed outside home. So we have another second presentation by Esther Chu. Esther will be talking about a new innovative method of for measuring food environment in Nepal. You have 10 minutes.
So today I'll be talking about the development of a new food environment measure in Nepal. So we've talked quite a bit about this week, but there have been significant shifts in food systems and food environments in the last several decades. And Nepal is no exception to these shifts. We've seen that overweight affects about 1/5 of all children, and consumption of processed foods high in sugar, salt, and fat affects about 50% of kids. So we really need a better understanding of this transition in diets and in food environments to really understand what shapes what we eat. So when I talk about food environments, I'm basing this off of the ANH conceptual framework that was first sort of come out in 2018 and then subsequently adapted in 2021, that organizes food environments under two domains, the external and personal domain. And then there's sort of 10 dimensions under these domains. And we know that food environments are quite complex as people access foods from a wide variety of sources. And there really is a need to better measure food environments, especially the dimensions that drive what we eat. And existing measures really have been developed mostly in high-income countries. And the most sort of prevalent measures are, like for perceived food environments, are quite time-consuming to complete. So the most common one is about 9 pages long, so it just takes time. And as a result of all these challenges, there really has been limited research on food environments to understand the impacts between food environments and consumption in low and middle income countries. So the objectives of this study was to develop a perceived food environment tool validated for the Nepal context. And we used this tool to determine the relationships between food environments and both healthy and unhealthy consumption among children. So we followed a 3-step process for methods. The first step was to actually develop this 10 survey item tool and validate it. And then the second step was to develop food environment analytic methods. So if we collect data using this tool, how do we analyze data for it? And we put together 3 summary measures. And then we use these summary measures to test relationships between the food environments and consumption. So the first step, so I'll go into each of these steps in more detail. So the first step was to actually develop this food environment survey, and we call it the Food Environment Rapid Assessment. We collect data on 10 perceived food environment dimensions for both processed snack foods and for vegetables, so sort of a proxy for unhealthy food, a proxy for a healthy food. And there are 10 questions for each of these foods, and some examples of the questions are shown. We first engaged stakeholders through expert consultation, so these are food environment researchers, nutrition experts, and we sort of got at a first version of the tool and pilot tested it with 146 women in Nepal representing both rural and urban areas. And we were able to implement this tool in the Suhara 2 annual monitoring survey that actually represented about 42 districts and 65% of the country and collected data on 3,600 households. Then we also validated this tool for content, face, and criterion validity. Second step was putting together these food environment summary measures. So we wanted to put together 3 measures that kind of looked at food environments in different ways to answer 3 key questions. So we wanted to understand our food environments in general associated with consumption. So kind of to get at a crude measure of food environments. So we put together a food environment score. These scores were sort of separate for processed snack foods and a separate score for dark green leafy vegetables, and these scores scaled from 0 to 10. And these, to arrive at the score, we would sum responses from each of the dimensions in the survey tool. So if we understand that food environments in general are associated with dietary consumption, what are the specific food environment dimensions that drive this relationship? So we looked at specific sort of those 10 dimensions and kind of constructed scores for each of those dimensions. And then we looked at different food environment types, so categories of and groupings of food environments to look at that relationship with consumption. So I want to go in a little bit more in depth in what I meant by food environment types. So we had the luxury in this survey tool to collect data on processed snack foods, so an unhealthy food, and a healthy food, dark green leafy vegetables. We had scores for these 2 types of foods ranging from 0 to 10 for each. So we were able to actually classify the households based off of this classification scheme, and it has been used actually in Mexico and Brazil already. So we just adapted it to the Nepali context. So to go into this a little bit more detail, food abundant area. So living in food abundance means that there's a high sort of processed snack food environment score. So availability, accessibility, desirability, convenience of processed snack foods, but also availability, convenience, of accessibility of vegetables. So high scores for both types of food. And then a food poverty area or a food swamp is where we have a high processed snack food score, so high availability, high access to processed snack foods, but a low score for dark green leafy vegetables. And then the food oasis is kind of like the happy spot, is where it's sort of the preferred classification, where there's a high food environment score for vegetables, so high availability and access to vegetables, but a low food environment score for processed snack foods. And then a food desert is where there's just a low score for both types of food. So we use these three summary measures to test relationships between food environments and these outcomes of interest. And these are mainly the sort of IYCF standard indicators of minimum dietary diversity, zero fruit and vegetable consumption, unhealthy food consumption, and unhealthy diet, which is a composite indicator of not reaching minimum dietary diversity, and also daily consumption of processed foods high in sugar, salt, and fat. And we used linear mixed effects models to estimate risk ratios. Just going into some of the results, we found that higher processed snack food environment score was associated with unhealthy diets, and then a higher food environment score for vegetables was associated with reaching MDD. So this is great. We know already that food environments are associated with consumption, but just some evidence around that. And then, so if we know that food environments are related to consumption, what are the dimensions that drive this relationship? So the dimensions that drove relationships with unhealthy diets were mainly availability of snack processed foods and convenience of these types of foods. So those had sort of the strongest relationships with unhealthy diets. And in terms of what dimensions that drove the relationships with having a healthy diet, were dark green leafy vegetable product properties. So these are food safety and how clean the vegetables are, and accessibility. In terms of food environment types, we found that living in a food abundant area is associated with consuming healthier foods as well as consuming unhealthy foods. Living in a food poverty or food swampy area, you're less likely to reach minimum dietary diversity. In a food desert where there's low scores for both types of foods, you're less likely to reach minimum dietary diversity, but more likely not to consume fruits and vegetables. And then living in a food oasis area where there's a high score for vegetables, but a low score for processed snack foods, is protective against unhealthy diets. So just to summarize, so a higher food environment score for vegetables is associated with dietary diversity as protective against unhealthy consumption. And then a higher processed food environment score is also associated with consuming unhealthy foods and not reaching minimum dietary diversity. So what drove these relationships are the convenience and availability of processed snack foods with unhealthy diets, and then food safety and accessibility of fruits or of vegetables were key drivers of healthy consumption. So this food environment rapid assessment tool can be used as a validated measure in Nepal, and we were able to insert this into an ongoing household monitoring survey. And there really are potentials to use this more broadly to identify areas of risk for low infant and young child feeding practices. And going to some future directions, so the Transforming Agri-Food Systems in South Asia initiative, which is part of 1CGIAR, has pilot tested and used this tool in India, Bangladesh, and Nepal. They've adapted it and incorporated it into their surveys. And really exciting is that they collected data on adolescents, women, and men, so sort of expanded that population. And they've also incorporated more foods, so eggs, banana, dal, and fish. So they've expanded the food groups that we're using this tool on. So that sort of analysis from that, those surveys are ongoing. There's also potential to use this tool with data visualization to map out where food environments could be improved or could be used, or maps to sort of target implementation strategies. So there's a lot of potential in that. And then also we demonstrated that you could easily insert this into a household monitoring survey. So future directions around that. Thank you.
Thank you so much, Esther. We will now have a presentation to predicting micronutrient intake inadequacies in data constrained settings using machine learning.
Yeah, so my name is Kevin, and I'm part of a new project at the World Food Program called the Modeling and Mapping Inadequate Micronutrient Intake Project, or MIMI. And on behalf of all my MIMI colleagues, in particular Vasia Vukulatu, who is our principal data scientist, I'll be presenting some very preliminary results from one arm of our project. So food security monitoring and assessment play a central role in our activities at WFP, and these activities are aligned with the UN's second Sustainable Development Goal of ending hunger and ensuring access to safe, nutritious, and sufficient foods. Monitoring food security plays a pivotal role in ending hunger, and including a nutrition lens within food security monitoring can help us encourage our food assistance programs to simultaneously make diets healthier and more nutritionally adequate. So, however, a global dearth in high-quality dietary data limits our ability to monitor nutrition indicators such as micronutrient adequacy, as highlighted by the global report on the state of dietary data published jointly by FAO and Intake. Where data exists, many indicators have been developed to assess micronutrient status and its risks at several points on this continuum. In addition, prior research has helped us conceptualize some of these causal pathways and identify potential risk factors. However, without dietary data to support these monitoring efforts, there exists a large data gap which stands as a barrier to identifying vulnerable populations. In the context of food security, the Hunger Monitoring Unit at WFP has developed a method using a wide network of phone surveys and a machine learning approach. Okay, so before jumping into our methods, I wanted to point out two considerations to help contextualize how these results apply to our current work streams. So first, this analysis focuses on model construction in the context where we have data to work with. We're not applying this model right now, but rather understanding the performance of the model through splitting and comparison within the same data set. And then second, we're only focusing on a single correlation pathway where our target focuses on quantifying risks of inadequate micronutrient intake, and our inputs are measures of socioeconomic status and diet quality. So this is by no means the final model, but rather seeing whether these underlying risk factors have any predictive power at all. So basically, these results are just letting us know whether or not we're on the right track or if we need to fundamentally change our approach. So with that said, here's a general overview of our methodological approach. I've divided it into three major components, which I'll go into detail right now. So first, in terms of the data source, we use the 4th Socioeconomic Survey of Ethiopia, which is a nationally representative HCS panel survey. For predictive inputs, we were able to draw from 14 different modules, which range from education and labor to time use and housing conditions. For our targets, the food consumption module included 66 predefined food items collected using a standard 7-day household recall. Next, for our model components, so for our targets, we classified households as apparently inadequate of zinc and vitamin A. We use a parent intake approach, which assumes proportional distributions of food based on household member energy requirements and nutrient reference values defined by work done by Lindsay Allen and colleagues. Vitamin A and zinc were selected as a first test due to their differences in characteristics. So we have a vitamin versus a mineral micronutrient. They each are sourced from varying food items and each have varying class imbalances. For our predictive variables, we feature engineered 27 independent categorical variables, which describe various dimensions of socioeconomic status identified by literature review, as well as components of diet quality from existing measures and from local definitions. And to construct our model, we selected from a number of supervised classification model approaches, considering the trade-offs between interpretability and accuracy. So out of the interest of time, today we're going to be presenting our dominant model, which was the XGBoost classification algorithm, or a variation of a tree-based model. For a comparator, or the null, which incorporates no machine learning, we generated a dummy model which generates predictions assuming each classifier has equal probability. And for both of our models, we randomly sampled 80% of the data to train the classifiers, and then 20% of the data to test the model's predictive performance. Okay. And then finally, for the performance evaluation, we use 4 commonly used metrics: accuracy, which is the proportion of correct IDs over all households; precision, or the data science term for positive predictive value; recall, or the data science term for sensitivity; and then the F1 score, which is the harmonic mean of the precision and the region. Okay, so that's the model. Let's jump into some of our results. So first, how does the model perform when evaluating at the level of the household? So for zinc, the XGBoost model performed better than the dummy model across all performance metrics, suggesting some evidence of predictive power. The XGBoost model correctly classifies 69% of households in total, as demonstrated by the confusion matrix. The predictive inputs with the largest impact on the model included recent consumption of pulses, nuts, and seeds, and recent consumption of tests. And the next two most predictive models were socioeconomic variables. More specifically, school attendance versus dropouts for school-aged children in a household. Next, for vitamin A, the XGBoost model performed better than the dummy model across all performance metrics. The XGBoost model correctly classified 77% of households in total, and predictive inputs with the largest impact in this model included recent consumption of NSAID products and recent consumption of fruits. Similar to zinc, the socioeconomic variables with the greatest predictive power were attendance versus dropout rates, dropout for school-aged children within the household. So second, what do aggregated estimates of predicted data look like when presented at admin level 1? So here I'll present zinc and vitamin A together. So zinc on the top row, vitamin A on the bottom row. These first maps present the actual calculated risk of apparent inadequacy using the full sample to serve as our gold standard. These next maps present the predicted risk of apparent inadequacy using the testing data, where we compare the two maps against one another. So we compare zinc actual versus zinc predicted, and then vitamin A actual versus vitamin A predicted. And then to help facilitate comparison, each region's actual versus predicted estimates were plotted against one another, where a greater distance from the red line indicates a greater deviation in the estimate. Points above the line indicate the prediction is overestimating, and then points below the line suggest that the prediction is underestimating. So for both micronutrients demonstrated agreement between actual and predicted estimates. For zinc, we observed a large underestimation for estimates in Addis Ababa, as shown by the dot close to the x-axis on the top figure. And then for vitamin A, we observed slightly larger deviations across several regions when compared to zinc. Okay, so what does this all mean? So these results show that predictive variables based off of socioeconomic and diet quality indicators show potential for predicting our micronutrient inadequacy targets. And overall, the approach we've tried here is pretty encouraging. So we feel pretty good about continuing the process of building our models moving forward. So I'll just note some of our next steps here. So first, for within country models, so we're still working on generating and improving our targets for prediction, including additional predictive variables for prediction as well, and then extending the estimates to admin level 2. So we've already calculated out to admin level 2 in Ethiopia. Now we're looking to see whether we can extend our predicted estimates to that level as well. Second, so between countries, we're working to harmonize and compare models across data-rich countries, where we're actually planning our first run of our Nigeria model next week. And we're looking to compare model performance across different countries and consider what a combined model using data from multiple countries would look like when compared to that country as well. So this is the ultimate goal to understand how we can apply these models in a data-constrained country. And then finally, we're scoping the integration of data from diverse sources. So right now, we're just focusing on using HCS and LSMS variables. However, we're looking to see if we can integrate as well data from CPIs, for the DHS, from mix, and from remote sensing data for environmental variables as well. So that's all I have for today. Thank you.
Thank you. So my name is Thijs Lange. I'm from Wageningen Economic Research, which is part of Wageningen Research. And together with my colleague Michiel van Dijk, we created high-resolution maps on grid level about food quality in Nigeria. So to support policy to end hunger and encourage sustainable and healthy diets, diet statistics on food consumption and nutrition are essential. And despite the growing number of open source data, the availability of detailed spatial information on food consumption and nutrition are still limited. And machine learning can help to, let's say, downscale statistics about, for example, food consumption to make high resolution maps. And this is already done in other persons that already do that for mapping poverty, population, also child growth. And what we eat is driven by multiple geo-environmental, socio-economic, and physiological factors. So diet depends on the physical conditions in the surroundings, so like soil type, water availability, climate, and are strongly shaped by the social context linked to culture. For example, food taboos shape what we see as food intended for human consumption and what we should avoid within a society. And in addition, globalization, economic growth, and urbanization results in a continuous change in diets. Like, for example, in low middle-income countries, we see there is a shift from traditional diets towards westernized diets, driven by an increase in household income and a change in the food environment in especially urbanized areas. And most of these drivers, they are spatially explicit. So the goal is that we are using spatial data on grid level together with household survey data to develop a machine learning model which can predict food consumption, and so in the end also a dietary quality indicator. So we used, for this study, we used the LSMS household survey data for Nigeria for the post-harvest period wave 4. And therefore we used the quantity consumed per households during a 7-day recall period on food item level. And in addition, we used the coordinations of the households, so of around 500 enumeration areas, and each has, within each enumeration areas are 10 households. So what we first did is we converted the consumed quantity from grams to kilocalories. Therefore, we used the national food composition table, and we corrected the per capita household consumption for the household composition. So consumption is expressed in adult female equivalent. And then we summed the consumed kilocalories per food item to food group level. And in the end, we derived the average consumption per enumeration area because we have 10 households in one enumeration area. So we took the average. In addition, we used, for explanatory variables, we used geospatial data about socioeconomic, biophysical, and biophysical indicators, and also high resolution data related to ethnicity and religion. And we trained, so then in the end, we trained this model. So with this high resolution input data with our household survey data to predict food consumption. In addition, we used the Sustainable and Healthy Diet Index, which is an index which says something about how far the diet is from the Eat Lancet diet, with the score, and it scores per food group from 0 to 3. So, for example, if you have eat not enough vegetables, then the score might be lower. But also, for example, if you're eating too much, consuming too much palm oil, then you might also score lower on this specific food group. However, we modified a bit this table, so it was expressed in grams, and we converted to kilograms. In addition, our household survey data has no information if the consumed grain is refined or whole grain. So yeah, it's just a modification, and it's still preliminary. So it's up for discussion. And here are the results. This is on food group level. So I just showing you now for 3 food groups. So for example, you can see here the consumption of rice, wheat, corn, and other cereals, and it's mainly consumed in the northern part of Nigeria. Also, and also more in rural in rural areas in the northern part compared to urban areas. While, for example, for fruits, it's more consumed in the southern part of Nigeria and mainly in urbanized areas. And fish consumption is mainly consumed in next to the coast. And in the north, it's also consumed, but then only in urbanized areas. And this is mainly driven by it's mainly dried fish. And the model performance depends per food groups, but some food groups performs quite well. For example, for rice, wheat, corn, and other, so the cereals, it has an R-square of 0.75. So then we used the dietary quality indicator, so per food group. So we scored per cell how good the food group scores. So you see that, this was quite logical that in the northern part, it scores 3 for the cereals, while in the southern part, it scores way lower. There's overall some consumption of cereals, so it's not 0. But for example, in when you look at fruits in the northern part, it's too insufficient, so it scored 0, and it's mainly consumed again in, of course, in urban areas. And you see clearly, for fish, you see clearly that the northern you go, the lower the score is for fish consumption. And then in the end, we took the sum of the 13 food groups, and then you get the overall dietary quality indicator, which is scored from, I don't have my glasses on, so I can't read the numbers, but I think it's from 10 to 20. So the diet quality is the highest in the southern part of Nigeria. In the northern part in Nigeria, the quality is highest in urban areas. And we also compared this with other high-resolution maps. So we compared this with child stunting and also poverty. And these data we didn't use as input data for our models. It's, I think, good to know. And you see indeed a negative correlation between the poverty headcount ratio and our dietary and the dietary quality indicator, and also negative correlation between child stunting and the dietary quality indicator. Okay, so conclusion. In general, the machine learning model can predict quite well the spatial pattern of consumption per food group. However, for the model performance of less consumed food groups like dairy and poultry performs less well, and it has to do with that it's more sensitive of outliers because you have less observations. And the advantage of this model approach is that it's easy to scale with additional data and other data sources. And this work provides a proof of concept of how this technique can be generalized to infer consumption and nutrition maps in regions with lack of survey data. Okay, and that was my last slide, actually. It doesn't go further. Oh, yeah. So thank you for your attention. And thank you.
Thank you, Tix, for the wonderful presentation. Now we have an online presentation by Thomas Asafa of the University of Georgia.
Thank you, everyone. My name is Thomas. I will be presenting work on measuring diet outcomes using high-frequency measures in Ethiopia. So we motivate our topic by presenting a trade-off between reference and recall periods in diet outcome surveys. These are two related survey design choices. The most familiar one is the reference period. That is a time over which a key outcome variable is measured. Recall period is the period over which the respondent's mind go back in time to recall what food was consumed. These two are the same in most in-person diet outcome surveys. And in that case, there is a trade-off. Long reference period is good. It increases the opportunity to capture better food consumption data when food consumption is seasonal, highly cyclical, or if there are occasionally consumed items. So in that sense, it reduces errors of omission. But long reference period also means long recall period, and long recall periods are associated with increased cognitive burden on our respondents in terms of remembering what food was consumed. So that increases recall error, and our respondents may revert to usual practices, may forget what was consumed, or do telescoping, meaning they may report consumption episodes that occurred outside of the reference period as if it is consumed in the reference period. Therefore, we develop and experimentally validate a new survey method to resolve the trade-off using short bounded recall periods. So our method extends the reference period without using a long recall period. So I will be explaining more in the next slide. Basically, we do this by conducting a randomized controlled trial in which we assign our respondents into the following two groups: the frequent bounded recall survey method, which is our treatment, and those assigned to this group receive 2 calls per day for 7 days, and the single interview in-person method, which is our control, and those assigned to this group report their diet intake during a traditional in-person survey. Our enumerators listen to the women describing meals and their ingredients and code consumption using a list of carefully selected 20 food groups. Then we empirically test differences across these two survey methods in diet outcomes, and we do that for 2 standard reference periods, 24-hour and 7-day. So to further explain our experiment, we use this diagram in which we present our treatment on the upper part and the control on the lower part. So let's say an in-person interview is happening today. Today is here on the left side of the diagram. And we're asking about, for example, yesterday. So for the control group, we ask the woman what she has consumed in the last 24 hours based on 20 food items. And then she reports consumption for all members in the last 7 days, again, based on 20 food items. So we have a 24-hour reference period and also a 24-hour reference period for the women and a 7-day reference period for all members. When I come to our treatment, we said we will call twice a day. So our calls are marked by the axis here in this diagram. And these vertical lines show the time when our respondent wake up from sleeping yesterday and the time when our respondent wake up from sleeping today. So for example, the afternoon call yesterday will be asking about this bounded recall period 2, which is from the time when our respondent wake up from their sleep until we call them. And the period after we call them will be collected, information about the period after we call them will be collected the next day in the morning call. And during that time, we'll be asking what has been consumed since we called until the time you wake up this morning. And we do this for 7 days. So we have 14 bounded recall periods. So these are short bounded recall periods, which allow us to construct a long 7-day reference period. So in terms of, we conducted this study in rural Ethiopia among participants in graduation from poverty programs, specifically participants of the Productive Safety Net program, who are also supported by Care and World Vision to graduate out of this poverty program. We randomly select 46 VESAs from enrollment records, and we work with all member households in a VESA. And within a household, we select one woman as our primary respondent. In terms of in terms of data collection, we first collect baseline in-person interviews, we conduct baseline interviews first, and then each household participated in our study for 7 to 10 days. And we have a sample of 646 households in 46 VESA clusters. This is, we estimate the following equation where Y is diet outcome, including women's dietary diversity score, household dietary diversity score, food away from home, eating order, and fasting. And everything else is pretty much standard. So coming to results, what we are presenting in this graph is treatment effects on dietary diversity scores. And so we are presenting both measures of 24-hour reference period, like the women's dietary diversity score, and measures of 7-day reference period, like the household dietary diversity score. And on the left side of the graph, we are presenting control and treatment group means, and on the right side, we are presenting coefficient plots from the specifications that I just showed you, coefficient plots of beta. So as you can see, for a 24-hour reference period, which is the upper part of the graph, we don't see any difference across these two survey methods. But when it comes to the 7-day reference period, the frequent and bounded recall method yields higher diversity score. And these results are also confirmed when we do a group level or food item level regression, where we test differences in probability of reporting consumption of these different food items. And as you can see, for a 24-hour reference period, these are the coefficients in blue. There is no difference in probability of consuming a given food group. But when it comes to a 7-day reference period, this means the coefficients in red, 9 out of 20 food groups are more likely to be reported through the FBR method, and some groups like fruits are less likely to be reported. And the explanation for that, respondents might be forgetting when we are asking them what they have consumed in person for a long recall period for 7 days, and but there is no difference when it is 24-hour reference period. So when we come to food away from home, we see food away from home is more likely to be reported through the FBR method. And when we come to eating order, this is the order in which householders participate in the last night's dinner. We see that there is lower likelihood of eating order reported through the FBR method, and we see children eating. We see respondents are less likely to report that children eat before the primary meal. And when we come to fasting, we see respondents are less likely to report participating in fasting through the FBR method. And in conclusion, we add new experimental evidence that the length of the recall period matters in measuring diet outcome, and we shed light on the specific mechanisms like forgetting, telescoping, and desirability effect that contributes to differences across these survey methods. And our results confirm that respondents face higher cognitive burden in reporting dietary intake data over a 7-day recall period, and therefore resulting in recall error. We offer a promising approach to extend respondents' reference period without increasing the recall period, which can help reduce error when measuring diet outcome. Thank you for much.
Good afternoon, everyone. Good afternoon, everyone. Thank you very much for the opportunity to share our initial finding from the food environment experience tools in the Action Against Stunting Hub. My name is Zahra. I'm research assistant from the Simeo Regional Center for Food and Nutrition, Indonesia. And today I will be co-presenting with Dr. Gregory Cooper from the University of Sheffield. Next, please. Over the last 2 years, we have been able to develop a tool that can characterize the availability, affordability, and accessibility of nutrient-dense foods in low and middle-income country setting. Given that in this setting, the food environment are often dynamics, involve informal sector, there is seasonality factor, urban-rural setting, and this tool also will be able to capture external and personal domain in food choice based on the Turner food environment frameworks. The result from this tool will be used to identify which place are the main source of the nutrient-dense foods and which outlets are underperforming, what is the main barriers from the customer perspective. All of this information will work as an input to the flow of potential health-sensitive intervention to increase access and consumption. Next, please. So I will introduce you to our tools. It's a semi-quantitative tools that consists of 4 modules. The first module is about the general characteristic of the respondent and the household. And then the second module is about the activity space, which are the place where the respondent goes to buy food for daily household consumption. Continuing with the set of questions about availability, affordability, and efficiency of the food. And the answer will be on the Likert frequency scale. We have 5 scale, rank from the never to always. So we ask the respondent, for example, during the past 30 days, how often the DGLV is always available in one of the vendor. In turn, Module C asks questions about different food environment domains, including the issue in food safety, desirability, and promotion. In the last module, we ask the respondent to rank the motivation of obtain or not obtain food from the list of 9. The next is about the methodology. So the tool has undergone various of the stage in the tool design, from the formative research that led by Professor Sunita Kadiala and Dominic Rowland to a series of cognitive testing to make sure that the question and answer are make sense in the local language and context. As part of the Action Against Stunting Hub project, this tool has been piloted and rolled out into our cohort in India and Indonesia. So the cohort participants are households with under 2 children that has been followed up since the pregnancy. During the 9-month visit, we asked about the dark green leafy vegetable, and the 12-month visit, we asked about chicken meat and organ. The survey is currently ongoing, and what we present here is the initial result. Next, please. Yeah, so this graph shows the pattern of the DGLV availability in different sources in India and Indonesia. So we convert it from the qualitative to quantitative metric. So the never will be 0 and always will be 4. And we average it for a different sources. If we see the y-axis here, the availability score, the availability score in Hyderabad, we have here the permanent market, weekly market, and mobile vendor as the sources that is often available. But in Indonesia, we only have one, which is the mobile vendor. And for the pattern, we see in Indonesia the percentage of total respondents who visit this source have a positive association with the availability of the DGLV. But in India, the association is slightly lower because of the Kirana store that didn't sell the fresh fruit and vegetable. So the detailed explanation will be provided by Dr. Gregory Cooper.
Hello, everybody. Great to be here today. And thank you, Zara, for the first 5 slides. Just to continue some of this initial analysis of the results, these graphs here show a relationship between the availability score, so the frequency of which dark green leafy vegetables on the left-hand side and chicken meat and chicken organs on the right-hand side, the frequency of which they are available from never to always as per the consumer's experience, versus the affordability, so the frequency of which consumers perceive these items to be affordable in each of these sources. And as you would expect, we see a positive association on a source-wise basis, that as the sources with higher availability tend to also be experienced to have the highest affordability as well. But interestingly, we have this slight residuals away from the one-to-one line here. I don't know if you can see my cursor just highlighting here the residuals, that actually, on average, the experience of affordability in these locations is less than the experience of availability. And we see similar overall pattern in Indonesia as well, both for dark green leafy vegetables and chicken also, although the kind of coherence to the one-to-one line is much better, perhaps suggests at this stage that affordability may be less of an issue, Although interestingly for chicken, we see a slight divergence away from this 1-to-1 line here, which we don't see for DGLVs. And these two graphs here then try to summarize 3 of the key dimensions of the tool. That is the respondent's experience of the frequency of availability, affordability, and also acquisition. So how frequently, when a customer or when a respondent goes to a source, how frequently do they actually acquire dark green leafy vegetables on the left-hand side, or in the 2 sources from India on the left-hand side, the 2 items, and in Indonesia on the right-hand side. So what we have on the x-axis is the difference between the affordability and the availability experience scores. So as you move left along the x-axis, the source on average becomes less affordable. On the y-axis, you have the difference between the acquisition score and the availability score. So as you move down the y-axis, the item, the product is acquired less frequently. And what you see, for example, in Indonesia is that the sources of chicken relative to DGLVs are relatively unaffordable, and they have lower rates of or lower frequencies of acquisition as well. But if you compare, say, to in India for chicken, we have the retail store, which despite scoring the affordability is considered to be on average less frequent, item is considered to be less frequently affordable than its availability. But actually, interestingly, acquisition remains relatively robust. The actual percentage difference between acquisition and availability remains relatively robust, and perhaps suggests that there's actually limited range of different sources for chicken, fresh chicken, and organs within Adaguda in Hyderabad. So as a consequence, people, despite being relatively unaffordable, people still have to source from this one particular source type. Now, I appreciate it's quite a complex graph, and still we have a bit of work to do to look further into these results. And I was just mentioning that affordability on that graph is one of the reasons why people do not acquire when something is available, but there are also these secondary reasons as well. When we know from the food environment framework, there are these personal domains, which I know Esther was talking about earlier, that actually in the module C of our tool, we do ask people about their experiences of accessibility, of physical safety in these markets, of hygiene and food safety. And we still need to do more work here. Actually, all of these results so far have been based on the summary statistics. We yet to really get hold of the household level data, which will provide more insights. But these are just some of the key highlights here that people do have concerns around the accessibility and the safety of the outlets which sell dark green leafy vegetables and chicken in both locations. These environments tend to be quite informationally poor, both in terms of advertisements, promotions, and also, again, concerns around food hygiene and freshness. As I say, we have more work to do here. And really, just the last couple of slides, just some of the implications of this work at this stage. The first is that there is a relatively limited range of outlets for these nutrient-dense foods in both of our study sites, where these items are reliably available and affordable. And whilst affordability appears to be a major barrier, there are also then these secondary factors as well, which we know about from food environment framework developed by Chris Turner and colleagues. And the very, very last slide, as I'm just conscious of time, the next steps is really to get hold of the household level data, which we've shown kind of an aggregated analysis at the source level, and then to start to think about clusters of different households, how they experience their food environment, and how that may link to the different outlets that they frequent. Also, we have the geocoordinates of households as well within our study sites as part of the cohort study. So there's potential geospatial analysis we can do. And one of the speakers earlier was talking about how drivers of consumption is really spatially explicit. So there's something we can do here as well. Last couple of points is we're hoping to develop, similar to Esther, a series of numbers which can summarize people's experiences of their food environment in a very small series of numbers. It can be applied to different environments, different food items as well. And lastly, we hope to make the tool available as well, and to be looked into, to be challenged, and to be applied to different locations as well. So I'll leave it there and say thank you very much, and thank you, Zara, as well, and looking forward to the discussion.
We thank both Zara and Grigor for wonderful presentations. As you have seen, all the six researchers, young researchers mostly, presented innovative methods and metrics on how to collect or gather as well as measure data on food consumption and intake and their outcomes, effects on health outcomes. Thank you. Thank you so much. So we're coming to an end. As you have seen, all the six presenters have presented with very innovative methods and metrics on how to measure food consumed outside home, micronutrient intake, and also using mobile phones and applications, which are very important to advance the ANH Academy's mission, which is one of the missions where nutrient intake and agricultural activities affecting health could be measured better using innovative methods and metrics. So by this, we'll give a warm applause to our all six presenters and we'll finish our presentations.